So in this example, if you're bitten by a venomous snake, it is necessary to be injected with antivenom to counteract the venom. A researcher claims that a new antivenom takes effect in 5 hours or 300 minutes. 12 snakebite victims take the antivenom, and the length of time for the antivenom to take effect is recorded. Here we have our values here. I want to state the standard deviation of this sample and the bias estimate of the population standard deviation and the unbiased estimate of the population standard deviation. Okay, so let's go to my calculator. I'm going to go to stats, and you will see I've added all the values in here already. And if I go to stat and I calculate them, my one variable statistics in L1, I check to make sure I've put it in correctly, 36575, that's correct. And so A part says my standard deviation of the sample is going to be 28.0628 or 28.1. That's the standard deviation of these 12 numbers. State the biased estimate of the population standard deviation. Well, this here is, this here also is the biased estimate. So this sigma is the biased estimate of the population standard deviation. If I now want to find the unbiased estimate of the population standard deviation, well, that is Sn sub 1, which my calculator is S sub x, which is the 29.3 to 3 significant figures. This value here is the unbiased estimate of the population standard deviation. And just to confirm, I've used 12 values here. And so when I create the confidence interval, I will use 29.3 divided by the square root of 12. That's the standard deviation that will be used in calculating the confidence interval that you don't actually see. It's in the background. Okay, and D part says create a 90% confidence interval. So if I then go to my stat, I'm going to test. It is a t-test because I do not know the actual standard deviation. I'm going to do an 8, a t interval, because the true standard deviation I do not know. I only know the unbiased estimate, which is 29.3. I have my data there. I want a 90% confidence interval, which is, so I am good for everything, and I get this. And so my confidence interval is 291.05, comma 321.45, and I will write that to 3 significant figures, 291, comma 321 minutes. So create, now in doing this, I should make sure I name the test. It is a t interval with the degrees of freedom being 12 minus 1 is 11. Okay, I should give the numbers where x bar is equal to 306.25. I've already written the standard deviation, and n is equal to 12. I've given the actual value, and the last step is we're going to interpret it in context. We can say we are 90% confident that the true mean time for antivenom to take effect is between 291 and 321 minutes. So we answer it in context. All right, so now E part says, have the conditions to create this confidence interval been met? Was the CALT used in creating this confidence interval? Well, the answer is no, it's not been met for many reasons. One, we can say that each snake bite, we don't know if they're randomized. So is each snake bite independent of the other? We don't know this at all. This is unknown. So they've not been met. As for even using the CLT, we did use the central limit theorem. This was the calculation we've used because we're looking at groups of 12 and how those groups of 12 would relate to other groups of 12. And we used it, but it was not appropriate to do so. We do not know, because first of all, we do not know if this set of data comes from a normal population. And if it's not, doesn't come from a normal population, we need to have n be bigger than or equal to 30, which it is not. So it's not appropriate unless it's taken from a normal normally distributed population, and we do not know that information. So we should never have made this confidence interval, but we were told to. F part then says, assuming the length of time for the antivenom to take effects follows a normal distribution. So we're going to assume that's true. Is there evidence the antivenom has reached its goal of being 300 minutes? Well, if that's the case, the answer is yes, it did reach the goal because 300 minutes is in my confidence interval. And so the claim appears to be true. And finally, what type of error may have occurred and what would the consequences be? Well, even though all our computations are 100% accurate, it is possible, this is a 90% confidence interval. So it is possible that 300 minutes is not actually the mean length of time, because it only does it 90% of the time. And we don't know if this particular sample we got was one of the 10% that doesn't capture the true mean. We'll never know. So if we stated incorrectly the antivenom may, because if we say it's true, the consequences, if there was an error, is the antivenom may have taken longer than 300 minutes, and that could have real human side effects. Or it could also be less than 300 minutes, which could be a good thing, but so more research needs to be done. So there are consequences to this value being, this confidence interval being one of that 10% that doesn't capture the true value. And we never know if we've made that error or not.